Howdy, it's tubalcain again, and in this episode of my machine shop tips, I'm going to continue where I left off in the last episode where I showed you how to file and clean up these lead flywheels here, and these are again the patterns made for me by Herb Blair. But I'm going to go ahead and machine these on the lathe and clean them up as if I was going to actually use them, and at this time I have no plans to make an engine that would use this size flywheel, etc. But since this is hard lead, a little different than what a lot of people do, I'm going to go ahead and show you how to drill and ream the hole, mount it on a arbor, and this is just 1/4 inch drill rod, and machine away so that the thing remains fairly well in balance and concentric with the center hub, I hope. Let's move over to the Atlas lathe. I'm at the Atlas Craftsman 12-inch lathe now, and notice that I have several chucks, and this chuck, 3-jaw chuck, has the reverse jaws. I like that so I don't have to reverse the jaws. I have chucks for every occasion, I guess you could say. And I've chucked this up on this lead flywheel. This is the curved spoke one, and I have avoided chucking it up in the area here where the gate was so that it'll run pretty true. And you know, I've cleaned up the periphery on first the bandsaw shown in the other video and then on the belt sander, so I hope that it runs fairly true. And I've taken a light cut here on the hub and faced that, and another light cut out here on the rim, and now I'm going to go ahead and center drill it. And this soft lead machines very well. Now let me switch to a bit that's, let's see, 15/64, and then I'll ream it at 1/4 inch. Now I'm reaming with the 1/4 inch reamer. I use no lubrication because the lead seems to be self-lubricating, and that's what makes that 12L14 leaded stock such a pleasure to machine. I've reversed the wheel in the chuck, and I want to machine off or face off the end of this. Remember, that's where the riser was, and there's about a 1/4 inch of excess lead there. I'll take a cut on the rim here also, but I didn't make note before that when holding a lead flywheel or a lead object in a chuck, they are most crushable and delicate. So be careful you don't put any muscle on them and deform the wheel. But now it's ready to machine. While I have the setup made, I'll go ahead and work with this 8-spoker. I'll face that hub. I'll machine the rim just a little bit. So easy to do when it's held in a chuck. And this is overly thick. You can't see the dimension here, so I'd like to take about 1/8 of an inch off of each side. I'll mark that a little more accurately here in a minute to reduce the weight. This is so terribly heavy. And then similarly as on the last one, I'm going to center drill, pilot drill, and 1/4 inch ream. Then I'll flip it around and machine the other sides, and I'm not going to show all of that. I'm having a bit of a problem with chucking this particular flywheel because it's so irregular on the outside here that no matter where I place the chuck jaws, there's a bit of a wobble or a run out, and perhaps you can see that. I've even turned it to the other side and it wasn't much better, so I might try turning it one more time. Let me show you, like this. perhaps machine a little bit off of the hub here, because remember this is tapered right now, but if I machine just a little bit off, then I can hold it, chuck it by the hub to do some, at least the reaming. See how that works. Either that or I have to go to a 4-jaw chuck where I can truly dial it in so that this part here, the hub, or really it's more important that the outside be concentric and run true, or it's going to vibrate at higher speed, not only in the lathe but on a model engine. They need to be in balance, so I'm struggling with that right now. I finally got this wheel to run at least semi-true, and I'm gripping it by the hub on the shorter end of the hub. It didn't work very well gripping it on this long hub. And this is pretty makeshift, but that's 1/2-inch mahogany as spacers. And I tapped it up against each one, and it's running fairly smooth. So I'm going to go ahead and drill and ream it in this position because I'm satisfied with that. Off camera. The hole is drilled and reamed, and now I'm removing an 1/8 inch off of the rim. I already did that on the other side, so I'll do a little bit of that on camera, and then I'll face the hub. I need to remove some of that too, and then it's ready to put on an arbor. I like the way that lead machines. It reminds me of turning Delrin. It's just so free machining and so soft. Alright, that's looking good. Reduce the weight of it, and now I'm ready to take it out of the chuck and mount it onto an arbor. But I'm actually going to go back to the curved spoke one now. I know I'm jumping around a bit, but I'm back to the curved spoker. But let me tell you what I did with the hole. This is a piece of 1/4 inch drill rod that I'm using as the arbor, and it wouldn't quite go into the hole, even though I had drilled that with a good 1/4 inch reamer. And then I put a hand reamer through there, and that seemed to, well, that's going to take nothing off of this one. Well, let's see now. I haven't tried it yet. I wonder if that'll go in. You see, it doesn't quite go in. So what I did on this one is I took this reamer. Now the reason it's red here is this is a 1/4 inch reamer that's 1/1000th over. That's why I put red on there years ago. I have one that has green on it. That's 1/1000th under. But since then I've acquired a bunch of other over and under reamers. They're really handy to have. So this will have to be reamed again. I just put this in the vise and run it through there. It doesn't take much off, but that way it will fit onto this arbor, and this was pressed on. Now I'm going to hold one end in that little buck chuck, a just true chuck that I showed that one video where I set it up, and it's within a 1/1000th. And to support it on this end, there's no center hole. That's almost too small to put a center hole in. I take a 1/4 inch oil light bushing, and I hold that in a Jacob's chuck, and that holds one end. The other end, I should say. Now, what keeps that wheel from spinning on the arbor, you ask? Because that's not a tapered arbor or mandrel as we know them. And I don't think I've ever had a project that was a larger diameter that didn't slip on the mandrel. So what I like to do is take a dog, and luckily I had a fairly small dog, and that is held on to the shaft with the set screw. And should it slip or try to slip, that will hold it on there. Also, it's up against the hub, so there'll be no tendency for the wheel to get pushed away from its original position. Alright, let's go on over to the lathe and set it up. There's the setup. Remember that this end is held in that little oil light bearing in the chuck, and I think my cutter is a little bit dull because I keep hitting little bits of foundry sand. And because this is 4 inches in diameter, I had to turn the speed way down, although I didn't think I would have to for such a soft metal, but I'm down to 164 RPM, and I'm using my super slow longitudinal feed, which is driven from the tailstock end. You've seen that in some of my videos. And now it's on power longitudinal feed. It's amazing how soft these lead chips are. You couldn't get cut on them if you tried. I'm feeding toward the tailstock. I seem to get a slightly better finish that way. And I do not intend to machine any more off the sides of the rim because I don't want to reduce that size anymore, nor do I want to take any more off the periphery than necessary, that is to clean it up. Now the other thick-rimmed one is the one I want to really hog the material off of, but here I want to take as little off as possible. And I'm getting close to the end here, so I'll take a look at it here as soon as it finishes. I think that's it. One little spot here that didn't quite clean up yet. There it is, the last pass. I'd like to break the corner with a file. It's a long angle lathe file. Did you ever see one of those? I talked about that in one of the videos. Long time ago, someone sent that to me. Alright, I believe this is done. There it is. Basically ready to use. Little imperfection there that I didn't machine out. Pretty decent finish. Abrasive cloth does not work very well on this, so I did not attempt to clean it at all with abrasive cloth, and the files load up like crazy, so filing isn't a very good option either. Okay, that one's done. Now I'm going to turn my attention to this one. I won't show it all to you, but you might have said, why didn't you go ahead and paint this before you machined it? And I would immediately retort, that's what I normally do, because then you don't have to do any masking. Color of your choice. So I think just for the heck of it, I'll go ahead and spray paint this and then mount it on the mandrel and continue this on the morrow. Well, it's the next day. I did paint this maroon simply because that's what I had plenty of. And I'm going to mount this in the lathe now and go ahead and machine it. And I'll face this rim on this side and on this side, followed by the periphery. And I'd like to take about 1/8 of an inch off, which is going to reduce the diameter, of course, but It's just so very heavy. Now, some of you are saying, what's with this guy and lead flywheel? What sense does that make? Well, I've had quite a few models over the years that had lead flywheels. And these are pretty old, but that's just soft lead. Matter of fact, this entire engine frame is made of lead. It's headless, as you can see. This came off of it would have been mounted on a boiler, something like this. I don't know what brand, but you've seen this in other videos. I know somebody's going to ask, what does your tool look like? And you can ground a high-speed tool just about any old way, but with an extremely sharp angle on it. That is the angle of keenness, almost like a knife edge, because it won't dull very much. It doesn't matter if the edge is rather delicate. First I'll face the rim, and this is on the dog side, not that you couldn't move the dog back and forth. And that takes the paint off. And I can take as much off here as I want. I'm not going to a dimension at all. You may have dimensions you're following, but I certainly do not on this. And now I'll flip it over so that the dog is closer to the chuck. Now, looking at it from this angle, I've flipped the flywheel around. I'll take a finishing pass now and then begin the periphery. The current diameter is about 4 1/16, and I'd like to take it down at least to the black line there, which is an indeterminate diameter that really doesn't matter much. So let me get started. It's initially an interrupted cut, which is a feature that might cause a flywheel to spin, or your work to spin on a mandrel, until I get it down to where the cut is no longer interrupted. So I'm taking a light pass right now. I'm about halfway to the line, and what surprises me is how hot the flywheel has become. I just didn't think there was that much friction. And I did use a little cutting oil that seemed to help, and that also surprised me. I think I'll have to sharpen the tool a bit because there was still some sand embedded in the rough casting, but now I'm through all of that and the interrupted cut is gone. Also, I get a tremendous burr as the cut is completed, so I'll have to chamfer the corners. I'm getting pretty close to the line, using power feed now. Now watch, it'll really lay over a burr as it completes the cut. And this is my final pass, and I'm feeding toward the tailstock. I seem to get a better cut that way, and those pesky chips are wrapped around the mandrel. I'm experimenting with abrasive paper, and I take it back, but can you see the dust coming off? But the wheel is so hot, I'm almost burning my finger. But that turns it dull rather than shiny when I use abrasive cloth, and this is number 220. I'll try some finer stuff. And going to try this carbide tool. I don't think the angle is keen enough, but I want to see if that will take off that horrendous burr. Why is that spinning on me? Let's see what that looks like. Now the burr is still there. Still there. Alright, I think that's going to work. I'll do the same thing over here. And this is 500 grit. I'll put a little oil on that, see if it makes any difference. But I'm done. I'm taking it out as soon as I do the other side. I need to remove the paint off of the hub, but I'm very hesitant to put it in a 3-jaw chuck and face it because it will leave chuck marks on there unless I wrap it and go to all kinds of rigmarole. This is 2-aught paper. I wonder if that'll do anything to it as far as getting the paint off. Oh shoot. Too good to be true, actually. Similarly, I'll work that a little bit off camera. Okay, it's done, and I reduced the diameter quite a bit, as you can see. This is the original setting by over 1/4 inch. Which reduced the weight, and I have done that in the past with my other ones. This is really the same casting here. And I took it down so that the rim was much smaller and, well, a little bit narrower too. Now, I have not put any set screw holes in here, and that's what I normally do, but it's very difficult to drill and tap lead, and it's very easy to strip it out, so, but that's what you have to do. And there's one that well, that's got a little set screw in it also. I won't do that until it's necessary when I go to use them. But there it is as the pattern and finished. Similarly, the curved spoke. And which one do you like best? Let's weigh them real quickly here on the Honest Toledo scale. But I don't have the original weights. That's in one of the other videos. Holy Toledo! The curved spoker from Herb Blair weighs 17.5 ounces. The 8-spoker is 22 ounces, so really not that much difference between the two. This one could also be reduced by thinning it this way and reducing the diameter. On that one, 6.35 ounces, and I had reduced it to... You may find it interesting to note that aluminum weighs 168 pounds per cubic foot, lead 707, iron 438, and gold, if we could afford to make a flywheel out of gold, weighs 1,204 pounds per cubic foot, darn near double the weight of lead. That's free of charge. But notice the difference here between aluminum and lead. Again, this 8-spoker weighs 22 ounces, and the 6-spoker with aluminum, and I still haven't drilled it or machined it, weighs only 6.3 ounces. So if you want weight, you got to go to lead or zinc or cast iron or brass, but most of us with home foundries are equipped only to make aluminum flywheels. So that's what this video was all about, and I hope you liked it. a little bit about machining lead, which is something you don't do very often, probably never will do, but you might have found that of some interest. This is tubalcain saying so long, and I'll see you in my next video.